Hello and welcome. My name is Dorian and I'm a Learning Experience Intern here at SOC STEM. Today I will be discussing a special case of FEA in 3DEXPERIENCE's CATIA app in which a part is actually behaving more like an assembly. I have here an example part of a roof panel for my friend David. As you can see from the tree, it is actually composed of 3 separate part body containers, each acting like a part of an assembly. We have also applied a material to each of these part body containers. To start off our analysis, we will go to the Mechanical Scenario Creation app. Here we will do a structural analysis. And once we enter the app, I highly recommend turning on the Assistant tool. This can be found under the drop-down menu for Feature Manager. The Assistant tool will help us run through the steps needed before we simulate. Starting off in Setup, we will create a finite element model. I will name it FEM. When we create our finite element model, you may notice that our model disappears. This is simply because our 3D shape was hidden, and we can show it. To finish our setup, we will also declare a static perturbation step to solve our analysis. Now that we have completed the setup, we will go and create a mesh for each part body container. Here, normally we would use a tetrahedron mesh. However, we do not need that many nodes, and we don't need that fine of a mesh to be able to solve our analysis. We will therefore use a Sweet 3D mesh. Here, we'll select the left rafter and a mesh size of 30 millimeters and 2 layers. This is pretty coarse for a mesh size, and if we're unsatisfied with the results of the simulation, we can always come back and make it finer. Here we will mesh and complete the same thing for the right rafter as well as the decking. And for the decking, we'll actually set the number of layers to 1. This is because we plan on creating a shell for the decking, and we only need 1 layer for that. You will notice, however, when we create our mesh for the decking, it doesn't turn out the way we like. This is because our sweep limits aren't defined correctly. It is sweeping from the left face to the right face. We will remove these and instead define the sweep from our bottom face to the top face. And now when we create our mesh, it'll look much better. Now that we have finished creating our meshes, we can go to the parts and we will apply the material to the finite element model. You will notice that not all of our commands are here. Simply go down to the Properties tab, and now we can create a solid section for the left rafter, the right rafter, and a continuum shell section for the decking. And this is the reason why we only created 1 layer, because we are treating this like a shell to be able to account for bending and to be able to also calculate the rotation of the decking from the pressure. Now that we have finished creating our parts, we can move on to connections. Once again, this commands list is not comprehensive enough. We can move to the Connections tab down here. What we want to do is tie the decking to the rafters at their contact points where normally they would be bolted together. So when we use the tie command, we'll simply select the decking's bottom face as the main surface and the rafters' top faces as the secondary face, and press OK. Now that we have finished our connections, we'll move on to restraints. For restraints, we simply have to fix the displacement of the panel wherever it is connected to the roof, which is right here, as well as back here. And here we have selected all 6 faces. We can set the translation to be fixed into X, Y, and Z, and press OK. Now that we have finished adding our restraints, we'll add our loads to help solve our analysis. Here we can add a gravity and a pressure on the top surface of the decking where the tiles will be meeting it. Here we found through research that it will be around 3,600 newtons meters squared maximum, and press OK. Now that we have finished setting up our model, you will notice that everything is green. and we can simulate. Before we simulate, however, I would recommend to update the model and save as well. Once we have saved, we'll simulate. And using 4 cores is fine. 4 cores is usually the maximum allowable with a student license. So now we'll run through the simulation, and I'll get back once it's done. Now that our simulation is complete, we can close this window and the assistant. You'll notice that this looks very deformed, and this is because our deformation scale, if you look at the legend here, is very high. Simply go to the results section, double click on the von Mises stress, and we can set the deformation factor to 1 and lock the scale factor for all plots. When we click apply, it'll look much better. We also have a displacement plot. And this is how you do FEA for this special case in which a part acts more like an assembly. Thank you.